Hi everyone. This video will talk about drone camera calibration via neural and heuristic method. What we try to do in this video is to achieve automatically color calibration and vignetting correction. The important reason for color and brightness correction is that first, we need the stereo cameras to produce the same color and brightness on the same object observed in the scene. Second, we need the color and brightness to be consistent across different viewing angle and camera locations. In this work, we have presented a fast neural color calibration chart recognition and localization approach, a heuristic approach to enable automatic color calibration, and a novel approach to reduce the vignetting effect. In our method, we first use a neural model to recognize and localize the color chart. Then, we use a heuristic approach to achieve color calibration. At last, we reduce the vignetting effect through a sequence of images. We use the Open Images test set as background and some color calibration charts as foreground, with lots of data augmentation, to generate our dataset for training. Then, we train a U-net to predict both binary parsing and corner heatmap from the input image. From the predicted parsing and heatmap, a homographa transformation could be calculated. We then project the color chart to a nominal square. Canny edge detection is then applied and the grid of color patches is retrieved by a simple clustering. After that, we enumerate each row and column to find the line with a minimum standard deviation of the color gradient, which represents the grayscale patches. We could then recover the white balance through them because they have the same value on each channel in sRGB color space. Vignetting effect is a reduction of brightness toward the edges and corners compared to the center of the input image. To reduce such an effect, we assume the brightness of pixels as a 6th-order polynomial of the distance to the image center. Through a sequence moving the color chart, we could fit a curve using the least square method to retrieve the vignetting function. As illustrated here, our method could generalize to arbitrary color charts with similar patterns. Here are some experiments in different scenes. The video shows the whole process of our method. The top left is the input image, the middle columns are the prediction of the network, and the process of finding grayscale patches. The bottom left is the calibrated image but with vignetting effect. The top right shows the dynamic fitting curve of our method to regress the vignetting effect. The bottom right is the final recovered image with vignetting effect reduction. Thank you for watching.